Hello class, this is lesson 5-2 about real numbers, and in this lesson we're going to be talking about different types of classifications for numbers. The first are whole numbers, and these are the types of numbers that you've learned since kindergarten. 0, 1, 2, 3, 4, 5, and so on in the positive direction. Now integers include all of those whole numbers, 0, 1, 2, 3, 4, and so on, but it also includes their negative versions, so -1, -2, -3, -4, and so on. So those are integers. Now rational numbers, typically you think of them as fractions, so it's going to be any number that's written as a fraction. Now, this can also look like a decimal, and so you may not know if it's a fraction or not. So you want to look for either a terminating, which means it ends, or a repeating decimal. So if you find that, then yes, it can be turned back into a fraction or a rational number. So instances include 1/2, 3/4, -0.6, 0.3 with a bar over it, or even -19 over 21. Those are just a couple examples of rational numbers. Now for irrational numbers, it's basically the opposite. So it's any number that cannot be written as a fraction. So it could also be in decimal form. And if that's the case, you're going to see a decimal that it goes on forever, so it does not terminate, but also it does not repeat, okay? And so there's a variety of different irrational numbers out there. Pi is one of them. So here are 6 examples, and I just want us to look at them and see if they are rational or irrational. So 2/3, obviously it's already written as a fraction, so 2/3 is going to be rational. The next is square root of 100, which is 10. 10 can be written as 10 over 1, which is a fraction, so square root of 100 is rational. Now the square root of 19 is not the square root of a perfect square, so it's going to come out pretty ugly on my calculator. So this is going to be an irrational number because that's as simplified as it can be. Now -5/6 is rational because it's -5 over 6. The square root of 6 is similar to the square root of 19. It does not come out evenly, so it's going to be an irrational number. The final one is the square root of 16 over 25, which is 4/5, which is a rational number. So hopefully those examples made sense. So now let's look at a new series of numbers, and we're going to classify them however we can. Starting with 0.252525, repeating. Remember, a repeating decimal we can write as 25 over 99. And so in this case, it would be a rational number, and that's it. Looking at our next one, the square root of 100 over 4 is really the square root of 25, which is 5. So that is a whole number. It's also an integer, and it is a rational number because I could write it as 5 over 1. Our next example is negative the square root of 7, which I would need my calculator for. It's about -2.64575513, going on and on and on forever. So this would be an irrational number. The following example is -21 over the square root of 9, which simplifies to -21 over 3, which equals -7. And -7 would be considered an integer because it is negative. And also it's a rational number because I could write it as -7 over 1. My final example here is pi, which again I would need my calculator for. And so this would be an irrational number because it cannot be written as the quotient of 2 integers. And that's it. So to conclude this lesson, I'd like us to make one diagram to classify all these real numbers together. The smallest subset that we have are whole numbers. These start with the number 1, and then it is 2, 3, 4, 5, 6, going on in the positive direction. Added to these will be the negative versions of these numbers, and these would be called the integers then. So it's all of the negative and positive whole numbers, as well as the number 0. Now, expanding beyond that, we have rational numbers. So this includes integers and whole numbers, in addition to other numbers that can only be written as an integer divided by another integer. The opposite side, we have irrational numbers, and some examples that we already came up with are negative square root of 7 or pi, and there are others that you could add to this list. But that's it. So I hope that this lesson made sense, but please let me know if you have any questions when you come into class.